pull up this image. All right. So we learned that energy from the sun transfers to the Earth's surface, right? And then that energy is then transferred to the air. Do you remember that? That was like in our first lesson. We looked at the rocks and we saw that above the rocks, it got warmer, whereas the air where there was no surface, right, stayed the same. So we need that surface to transfer that energy to the air. Everybody with me? All right. We learned that Earth is split into two hemispheres by the equator, right? And that the equator gets the most energy from the sun. And we know that high energy is equal to high temperature, right? And so the poles are getting less energy than that equator. So we learned that the larger the latitude, which means the greater the distance north or south from, I put of the sun, that's wrong, of the equator, Ms. Jackson wasn't paying attention, the less energy it receives. So Ms. Jackson's going to fix that. The distance north or south of the equator, the less energy it sees, right? So the closer to the North Pole or the closer to the South Pole it is, the colder it's going to be. And last but not least, last lesson, we should have learned that the ocean currents, right, cause the surface temperature at a location to be different than what's expected. So the currents at the poles, right, the currents from the poles carry less energy, and the currents from the equator carry more energy. So when we looked last lesson at, and I'm just gonna pull up somebody's. So when we looked at investigating these two currents at A and B, at Buenos Aires and at Cape Town, we saw that the one from Buenos Aires carried more energy because it was coming up from the equator. And I just want to show what that looks like. So Buenos Aires was coming down from the equator, right? So this is going to bring down warmer energy. And Cape Town is coming up from the poles. So since that current is coming up from the poles, it's going to bring less energy. So it's going to make it colder there than we would have expected. And by Buenos Aires, it's going to make it warmer than we would expect it. So are we all on the same page now? Anybody
Yes.
Yes. Okay, so no questions. Sounds good. Yeah, you have a question? Yes. What's that?
How can I see the
How can you see what, baby?
How can I see basically because you was talking about
You don't see the videos, or you don't see what I was just showing you?
I don't see what you were just showing.
Okay, I'm gonna stop sharing and start sharing again. Let me know if you can see my screen. Okay. Janine, can you see it now?
Yes, I can.
Yeah, okay. So I'll show what I just showed you before again. So if we're looking at Buenos Aires, right, we see that the current by Buenos Aires is coming down from the equator. And since that current is coming down, it's going to bring warmer temperatures than we would expect. Here at Cape Town, we see that the current is coming up from by the poles, right? And since this current is coming up, we're going to see that it's going to be cooler than we would expect it to be. Does that make sense now, Janaya?
Yes.
Yeah. Okay.
Ms. Jackson?
Yes, baby.
I have a question.
Yeah.
So does that mean that Cape Town has more energy, or does the other one have more energy?
Well, if it's colder than we expected, would it have more energy or less energy?
Less energy?
Boom, less energy, exactly. So Cape Town is having less energy than we would have expected, and Buenos Aires would have more energy than we would have expected.
Okay.
Okay, sounds good. All right. Woo, glad we knocked out that misconception. Y'all are on it this morning. Okay, so we're going to start lesson 2.3, and we're actually going to skip the hands-on part. I'm going to post a video tomorrow for you guys to watch that. we're going to go straight to the simulation today, right? And so Ms. Jackson's going to do the simulation with you. We're going to be looking at the current map mode to see what's happening with these two locations, one located near a warm current and the other located near cold current, right? So we want to see how these currents are affecting our temperatures, okay? So we're going to go to the sim. And everybody here is able to log on, right? I don't have to show you how to log on to Amplify. So anybody here would need that help?
No. No.
Perfect. So we're going to change our temperature view to surface. We're going to be looking at the surfaces. And I'm going to put my sensors at locations 4 and 5. So location 4 is right over here. And location 5 is right over here. And remember that these are simulating actual continents, but they're not real, right? So we're going to record the air temperature. What I want you guys to do is, let me turn off the presenter mode for 1 second so you can see what I've done. Is in your books, I want you to make a chart similar to Miss Jackson. So I think you guys should be able to see it. Where you're going to put sensor 4 and sensor 5, starting air temperature, final in temperature, and you're going to tell me if the current's warm or cold. So you're going to make your little chart. And it's got sensor 4, sensor 5. Right? Starting air temperature. Miss Jackson don't know she points the right thing. Final air temperature. And whether the current is warm or cold. So while you guys make yours, Miss Jackson's going to make hers on this big old poster board that she has down here. So I'm just going to hold this up while I create. So the first column should have sensor 4 and sensor 5. Okay, so starting temperature. Oh, Janaya left. Final temperature. And your current. Okay, so Ms. Jackson made a very, very large chart. And so you can see, or let me know if you can't. I put starting temperature, final temperature, my current, sensor 4, and sensor 5. And we're going to be recording data for that. You can also see it if you're on Amplify right now. You can also see it if you go to number 3. So you'll see that chart if you go to number 3. I'm going to project my screen so you can see what that looked like. Welcome back, Janaya. So your chart should look like this. A nice, better version of what Ms. Jackson drew. Just unmute yourself and let me know when you're good, when you have it done.
I have it done.
Okay. Oh, welcome, Sharasia. It's good to see you. So we're getting this chart right here down in our notebooks. And Ms. Jackson's going to get started in about another minute. So I'm going to give you guys till 10:20 to get this chart down on a piece of paper and your notebook. Wow, a minute is a long time, guys. All right, 10:20. Okay, so in our starting temperature, we're going to be recording these temperatures we see here for our air. So our temperature 4 is 17.2 degrees Celsius, and our temperature for sensor 5 is 17.2 degrees Celsius. So I'm just going to write that on my handy dandy chart paper. And what that should look like in yours, right, is 17.2. 17.2. And we're going to now run this simulation until the temperature stabilizes. So until it's no longer changing. So let's press play. Let's speed it up because I'm impatient. All right, so it looks like our temperatures have stabilized, and so the final temperature of sensor 4 is going to be 19.9 degrees Celsius. And the final temperature for sensor 5 is going to be 24.1. Right? Let me just run it for a little bit more to make sure that it stays at those temperatures. Yep. Okay. So, what type of current is running past sensor 4? What type of current do you guys think is running past sensor 4? So we're looking at the surface. We're looking at 4 and 5, right? And we expect the air to be 17.2 just for this latitude. And we got these final temperatures of 19.9 and 24.1. So do we think it's a warm current or a cold current running past? Valerie, you said what?
A cold current.
Running past where? Sensor 4 or sensor 5?
Sensor 4.
Exactly. It's a cold current running past sensor 4. And what about sensor 5?
A hot current.
A warm current. Exactly. A warm current. So Miss Jackson's going to post her really terrible looking chart later. But for right now, she's going to show you what that looks like on Amplify. So my final air temperature was 19.9. Might help if I write numbers right. 19.9 and 24.1 respectively. And so this is a cold current. And this one's a warm current. Right? We can see, and we even saw that when we looked at like the images, right? If we press play and we look at what's going on in the water, right? If we're watching this current, we can see it pushing up that water from the equator by number 5. And if we look over here by number 4, we can see that water coming down from the poles, right? We can see those currents moving down. So what we're going to answer now is, at which location does the energy transfer to the air? At which location does the energy transfer to the air? From the water to the air, I'm sorry. From the water to the air. What do you think, Janaya? Which location is the water transferring from the water to the air? Here's a hint. It's still here. Somebody help her out. Let's go. Jay, which location do you think the water is transferring, the energy is transferring from the water to the air?
Sonar 5.
Exactly, yeah. It's sensor 5, right? We see that the energy is transferring up from the water to the air, right? And that makes sense because this temperature is getting much more warm than we thought it would be. And so sensor 4, the energy is transferring from the air to the water. Did I say that backwards? This is sensor 5. So sensor 5, sorry, I just said that backwards. Sensor 5, the energy is transferring from the water to the air, right? We have this warmer water giving energy to our air, making our air temperature higher. And sensor 4, we have our energy going from the air to the water, right? And if we look at our water temperatures, we can even see our air over here for sensor 4, right, is warmer than our water temperature. And over here, our water temperature is warmer than our air temperature. Okay, so what I want you guys to answer, I'm going to drop a, what do you think? Oh, don't worry about that. So based on that, I want you guys to answer the question, why is the temperature shown on sensor 4 different from sensor 5, even though they're at the same latitude? Why is the temperature shown on sensor 4 different from sensor 5, even though they're at the same latitude? And I'm going to stop sharing for a second because I'm going to drop you guys a Padlet. So I'm going to drop a link in the chat and you're going to answer the question at the link. Remember that the title should be your name. So when you answer the question, you hit the plus sign and write your answer. The title should be your name. Okay. So let me go to our chat. So here we go. So you're going to click this Padlet. Let me share my screen again. So you're going to go to the chat and click on Padlet. And you're going to answer the question. So you're going to hit the plus sign. And the title should be your name. So Miss Jackson is going to be mine. And I want you guys to answer the question, why is temperature shown on sensor 4 different from sensor 5, even though they're at the same latitude? Yes, I see Jaden's there already. I see Janaya. Oh, that's not on it. All right. So I see Sharaja's here. Yes, Sharaja. Fallon and Sherry. Give you guys a minute to write that, and I'll leave the simulation up for you guys so you can think about it. There we go. That's what I was looking for. All right. So, oh, Belly, you're not done yet. I'm sorry. But I see that Valen and Sherry is talking about why they're different, even though they're at the same latitude. Jaden, the reason sensor 5 is because of the heat. Because of the heat from what, Jaden? So you're on the right track. So reason why sensor 5 is warmer is because of the heat from what? You're on the right track. Yes, Jay. Yes, Sherry and Valen, I see you. Sensor 4 is colder than sensor 5. And just tell us why that is. Yeah, I see you. What causes that difference? Sharisha, do you need me to pull back up the simulation so you can see what causes that difference? So what's happening that gives them these two different temperatures? It's going up and it's going down. So, Bella and Sherry, good. Just be careful with the it, right? I want you to be sure that you're making sure that what's going up and what's going down is those currents. So you're right. And sensor 4, the current is going down from the pole. And sensor 5, the current is going up. Excellent. So now the temperature 4 because. Okay. So I think maybe some of us need an extra minute, or maybe my page is just delayed. Let me refresh my page. All right. So for my friends who might be getting a little stuck, that's fine. Let's look back at what we saw here. So if we look at the beginning, right, both of these locations had the same latitude. So they were expected to have the same temperature, right? They had the same starting temperature of 17.2 degrees Celsius, right? And as we see, as energy is transferred to these locations, right, we are seeing that there is this cold current, right, being pushed down from by the poles down past location 4. And that's making that's making it colder over here than what we would expect it to be, right? And if we look, that's why the water temperature is lower than what we expect it to be, right? We would expect it to be around 20 to 21 degrees, right? Based on the location. However, because the water is cooler, then we have this cooler than expected air temperature, right? And then if we look at location number 5, if we look at sensor number 5, we are getting a current that's being pushed up from over here by the equator. And we know the equator gets the most energy from the sun. So as that energy is being pushed up, pushed up by this location number 5, it's getting more energy transferred from the air, from the water to the air, right? So as we look in the water, from the water to the air, it's making this temperature rise to 24.1 degrees. Okay? So I hope that helped my scholars who were still struggling with what to see here. So today. So later on when you go on Amplify, or some of you may be already there, just be sure to hand in the work that we did. So this lovely work you did with your chart, you're just going to write that in. And those answers that we had, you're going to write that in. So water is transferring energy to the air at sensor 5. And we know that at sensor 4, water energy is being transferred from the air to the water. So we're going to do some discussion about what's happening here at Buenos Aires and Cape Town. So I want you guys to, what in the world? Looking at the map, what I did see about my trash just trapped in this. I don't know. I do know what that. I'm going to close the sim. And thank you guys for responding here. I'm going to close this off too. So what I want you guys to do is answer, Ms. Jackson, you guys should actually answer this in the chat. I'm not going to start a new Padlet. Based on what we learned today, right, is Buenos Aires, the blank transfers energy to the blank. So you're going to fill that in with the words ocean and air. So in Buenos Aires, what transfers energy to what? Does the ocean transfer energy to the air? Does the air transfer energy to the ocean? And you're going to answer that question right here in our chat. So I want to close this. Here we go. In Buenos Aires, the blank transfers energy to the blank. Look at what's going on with the current. Where is it coming from? It's coming from down from the equator. Y'all are all shot today? Nobody's gonna say nothing? All right, do you guys want to do the first one together? Unmute yourself if that's the case. Say yeah.
Yes.
Okay. So let's do this first one together. So somebody tell me, where's the current for Buenos Aires coming from? Is it coming from the equator or the poles? Anybody?
The equator? Equator?
Yes, it's coming down from the equator. So we then expect that energy to be what then, Janaya? We expect it to be warm or cold bringing down? If it's coming down from the equator is, somebody help me out. The equator is hot, cold. What is it? What is the equator? I got too many kids here, so y'all will be quiet.
Warm.
Exactly. The equator is warm. So if we're pushing down